All right, here we go. I am looking at the packet of material, the white packet that I brought to you. It says at the top, College Algebra Final Exam Review by Adam Bowden. He is the teacher who put this together for us so that we all have a similar set of questions that we're working through. So I am looking at the test one material, which basically covers about questions 1 through 18 or somewhere in there. Okay. So depending on where exactly we cut our material. So, excuse me, to keep this video reasonable, I do not have time to work every single question for you. So we're gonna just kind of hit the highlights and see how it goes. So I'm looking at let's do number 2. Use the given conditions to write an equation for the line in slope-intercept form. Okay. Hopefully everybody knows which one is the slope-intercept form. That's y equals mx plus b. It's called slope because the m represents the slope, and intercept because the b represents the y-intercept. So this is my slope-intercept form of a line. Okay, so it says, write it in that form. The line passes through the point 3, 1 and the point -8, 3. Okay, so before I can do anything else, I need to have my slope. So m equals, sorry about that, y sub 2 minus y sub 1 over x2 minus x1, or depending on how you learned it, rise over run, or change in y's over change in x's, however you want to think about that. I'm going to call the first point my x1, y1, and the second point my x2, y2. So when I go to plug this in, and I'm going to move through these fairly quickly because I think you should know this material by now. This is from like week 1 and we are in week 15. So as we move through, if I'm going too fast for you, work the problem on your own and then come back and watch the video if you need help. Okay. So y2 is 3 minus, because there's a minus in the formula. Y1 is 1 over x2 is -8 minus, because there's a minus in the formula, 3. Okay. And as I work that out, 3 minus 1 is 2. And on the bottom, I've got -8 minus 3 is -11. And I say, okay, that's my slope. I'm not going to change that. I'm going to keep it as a fraction. And then to get this into its final format, what I need to do is use the y minus y1 equals m times x minus x1. This is my, okay, so this was slope intercept. If you're trying to remember which one's which, this is my point slope form of a line. Okay, so it's point slope. They call it that because we're using one of my points, and it does not matter which one, and we're using the slope. We're going to plug in what we just found right there, and the y and the x are just going to remain generic, so they are not going to change on me. Okay, so, and again, it doesn't matter which one's my y1 or my y2. I already nominated these. I'm sorry. I already named these as my X1 and Y1, so I'm going to keep with those. But if you wanted to use the other point, you would be fine. The problem is if you use this as your Y1, you have to use the X1 that goes in the same point with it, right? So Y minus Y1, that's a 1, equals the M we know is -2/11 now, right? Times X minus the X1 is a 3. Okay. So I'm going to distribute that -2/11 through. The idea here, remember, I need to get it into slope-intercept form, so I need the y by itself. So I'm going to distribute that -2/11 through before I do anything else. That'll be -2/11 x. A minus and a minus is going to give me a plus back here. And this 3 is really over a 1, right? So 2 times 3 is 6. 11 times 1 on the bottom is 11. Okay, so plus negative, negative, or negative or minus plus 6/11. Okay. All right. And then remember, I'm trying to get the y by itself. So I'm going to go ahead and get rid of this -1 by adding 1 to both sides. It'll go away on the left-hand side. I'm left with just y equals, let me speed this a little bit. Y equals this -2/11. X is going to stay by itself because it's the only X out there. There's nothing to combine it with. But this 6/11 and 1 is, I need to add those together. So if you're not sure, you can kind of come off to the side and say, I've got 6/11 plus, it's a 1. You could just write 1 and 6/11, but normally we try to get this as a improper fraction. So 1 with 11 on the bottom to get a common denominator would be 11/11. 11/11 would reduce down to be a 1, right? Okay, so that's how I get a common denominator there. So it's a plus 6 and 11 is 17 on the top. Keep the denominator the same, and I'm done. Okay, that is in the format they asked me for. Y equals, go back to the top. Y equals mx plus b. That's what they asked me for. I've got it in that format. I'm done. And remember that on these reviews for the final exam that I've given you, there are solutions at the back. So let me find your solution set. Well, why am I missing? 53, 54, there it is. Okay. I'm like, where is it? There we go. Okay, so here it is. Y equals -2/11 plus 17/11. Just leave that alone. We like it with the common denominator so that when I go to do something else in a minute, I've got it. All right, so that's it for there. Some of these questions are pretty straightforward using the graphs, so I'm not going to do much with them. So for instance, use the graph numbers 3 and 4 here. Use the graph to determine the function's domain and range. For instance, here I've got this graph right here. I can see that it starts at this point 0, -3. Okay, so when I go to do my domain, it's going to start at 0 because that's the x value. Remember, domain is left to right. So it starts at 0 and goes all the way out here and it goes to infinity, right? Okay. So for instance, number 3, domain could be 0. The 0 is included because it's right there with the solid dot, right? Solid dot. To infinity, and recall that we never actually hit infinity, so we keep that guy as a parentheses on him. And the range, and remember on range we go from bottom to top, so it starts down here at -3 on the y value, and it goes, again, this is an arrow going up and over, so it goes up to infinity. And again, the -3 is included. It's a hard bracket. Okay, because it was a solid dot, right? Solid dot. So that gets it a hard bracket and it goes from there all the way up. Okay, so be aware of that because, for instance, whenever you're dealing with number 4, the domain goes from, this looks like, that's 4 to, this looks like a 1 up to a 12, and those are not included because they are not hard or solid circles, so they're open circles, so both of those would be parentheses. Okay, the range seems to start here at y equals 1, starting from bottom to top, 1, and goes all the way up here to, it looks like 6. Okay, and that's going to be what? A hard bracket because this 0.6 is included. Okay, so remember that open circle, closed circle stuff. And the open circles translate into parentheses. The closed circles translate into hard brackets. And if it's an infinity, we always put a parenthesis. All right. Oh, excuse me. right where the graph is increasing, decreasing, or constant in interval notation. Okay, so interval notation ends up looking a lot like, well, it's this domain notation, right? But it ends up looking a lot like a coordinate point. So we have to be careful about this. But remember, it's always left to right on the domain, bottom to top on the range. So, and we tell where it's increasing, decreasing, or constant by using the X values. So as I trace this guy here, the first little piece is increasing. It's going up from left to right. And that is from way over here, x equals negative infinity, all the way to this point right here. It stops increasing. That x value, remember we're looking for x values, that x value there is going to be a 0. So that's number 5. Increase is, I'm sorry, it was negative infinity up to the 1, right? Now, when we do increase and decrease, we have to be a little bit careful because, yeah, this point up here is included. Oh, I'm sorry. That's not even my x value anyway. I said it, but I didn't write it right. 0. Okay. But yes, this value here is included, but we don't know because that point is a turning point. We don't know if it's increasing or decreasing. So when we have a turning point, we will use our parentheses. Okay. So that's one of the increases. Then it starts decreasing, but I see here, look, it starts increasing again. Oh, excuse me. So remember we used the little union guy? Union. So it increases here and it increases, or you could look for an increase over here. And this is the value x equals 2. Again, this is a turning point. So it's not going to be a hard bracket. It's going to be a parentheses or a soft bracket. So x equals 2, and then it's going to increase all the way up to infinity, and that's up and over, right? So 2 and infinity. Okay, that's my increasing sections. And then right here in the middle, I have that decreasing section. It decreases between x equals 0 and x equals 2. And again, both of those endpoints, the 0 and the 2, those are both turning points. So we don't know if they're increasing or decreasing. So they get parentheses, both of them. Okay, this is an interval notation. Okay. And then the last thing here says also write the local max and local min as points. Okay. As points, that's coordinated systems, coordinated points, right? So we got to give it that way. So the local max is right here. It's not the overall max because we know it goes to infinity. But remember, local just means I can isolate it. So I'm looking at this little area right here. And that point is 0, 1. And this is a point, a coordinated point. And the min is going to be down here at this point. Again, it's a local min. We know it goes down to infinity, but this is a local min, and it's at this point 2, negative 3. Okay. And again, these are points, coordinated pairs. So these two are only parentheses. They are not hard brackets. Okay, so remember that when you're dealing with those kinds of things. All right, this next one, number 6, it's very similar, so I'm not going to do the whole thing, but I do want to point out that number 5 did not have a constant, right? It had increase, decrease, increase, but this says areas of being constant in interval notation, okay? Right here on number 6, I do have constant, okay? Where is it? It's constant between this point here and this point here. So again, we use our x values to talk about that. So it's constant, it's flat between -1 and +1. That's the interval there. And again, these are turning points or cusps or whatever you want to call them. And in this case, they are not going to be a hard bracket. They are going to be parentheses. Okay, so we do have a constant area in there. We also have an increase here and an increase on the right-hand side and a decrease there. So number 6 has all 3 areas: increase, decrease, and constant. All right, moving on. Number 7 and 8 say use the sketch of the function plotted with a solid line to sketch the graph of this other thing. So here is, and again, it doesn't matter which one we do because they're both the same. I'll do 7, you do 8. Number 7 looks like, okay, it starts out here at the point -1, -1, and it goes up until I get to the point 1, 1. Okay, it's got this point, this going up thing going on, and then it goes down until I get to the point 3 and -3. Okay, so it's got a zigzaggy kind of thing going on here. Okay, and then we see it goes back up again till you get to the point 4 and 0. Okay. So there is my zigzag, and it's all about transformations at this point. So this guy is my f of x, and it wants me to find f of x minus 3 plus 2. Okay. So just a real fast reminder of what goes on whenever we deal with transformations. The numbers on the outside affect my y values. So this is a +2. It's going to go up 2. All of the y values, the entire graph is going to shift up 2. And this guy, remember what goes on inside of the parentheses, that affects my horizontal stuff. So this affects my x's left and right. And this is like, hey, my x-intercept would be at 0, but I'm going to move it. Oh my goodness, I'm sorry. I'm going to move it, and you have to fight your inner instinct because -3 would be to the left 3. But remember, this is the x-intercept. So what makes this equal 0? X equals 3 makes my x-intercept, right? So that's how I got to go with it, x-intercept. Okay, so this will move it to the right 3. Okay, so whatever I had here is going to move 1, 2, 3 to the right. Whatever I had here is going to go 1, 2, 3 to the right. We have to be a little bit careful because this guy's way down here. He's going to go 1, 2, 3 to the right. And I need one more because this point is at the point 4, 0. So when I move it to the right, it goes 1, 2, 3, all the way over there to the 7. 7 to the right. Well, 3 to the right, and that leaves me at 7. Okay, so that's the left to right shifting going on. Okay, that's what's inside of the parentheses. And then don't forget about this up 2. And again, every point, these are not necessarily going to be graphs that you can just plug into your calculator. There's no function that easily gives me this in my calculator. So I need to be able to do this by hand. I need to be able to move every point up 2. So if you're still not there, if you still haven't managed to do that process, you need to get to where you can. Okay, I really need you to be able to do this by hand. So this is the point 2, and right now it's -1, but I'm going to go up 2, so he's going to shift up here. Okay, this is now the point 4, +1, but again, I'm going to go up 2. So instead of 4, +1, it's going to be 4, +3. I might ask for points on this test. This was a 2 and a 1. Okay, this point right here was at 6, -3, but it's going to go up 2, so it's going to be at 6, -1. Again, remember, these individually change your x value or your y value, and you got to know which one's changing. Here, I'm just moving my y value up. The x value is already shifted left and right, so I'm just moving this one up. It is currently 7 and 0. I'm going to move it up 2, so it's going to become 7 and 2. Okay. So the basic shape of this graph stays as much the same as I can. It's still that zigzaggy pattern. So don't lose that as you shift things around. And my final answer is this blue guy. Okay, this one is f of x minus 3 plus 2. Okay, so we know what's going on there. All right. So there you go with that guy. You can work on the little parabola looking one here. Remember that this minus on the inside is going to move it to the right. This minus on the outside is going to move it down. And then don't forget this minus, this negative sign in the front, that is a flip around the axis. So whenever the x-axis. So whenever I flip this, this is going to be an upside down parabola, right? So don't forget that you need to flip it and do that kind of thing. Okay. Let's see. 9 and 10 say write a piecewise function to solve. Okay. So this is from section 2.2. It says, I'm going to grab this up. Number 9, I guess. Trying to decide which ones I want to work on. So number 9 says the charges for renting a moving van are $65 for the first 30 miles. $65 first 30 miles. Okay. And then $6 for every additional mile. That's really expensive. $6 additional miles. So in other words, if I drive 29 miles, it's still $65. 30 miles, $65. But if I drive 31, it's going to be the 65 plus the 6, right? So 71 for 31 miles. So it starts going up quickly. Okay. Assume that a fraction of a mile is rounded up. Write a piecewise function, y of your function to represent the cost of driving the van X miles. Then we're going to determine the cost for driving exactly 77 miles. Okay. So if you don't remember, piecewise functions end up looking like this. They have this lovely little brackety thing, and it'll have two different things going on here. F of x is going to equal, well, the first one's easy, $65 if we're going to use x for my number of miles. X is less than or equal to 30 miles. Okay, so that one goes pretty easy. Okay, no problem. But the next one is a little bit tricky because I'm going to add the $65 to the $6 for additional, I should dump the dollars on there. $6 for additional miles, but we have to do an adjustment step. Remember, okay, it's not, if in my case that I did a second ago, I said 31 miles. It's not 6 times 31, right? The 30 miles are already accounted for in that 65. So it's 6 times each additional mile over 30. So I need to make an adjustment step, which is take your total number of miles and subtract the 30. Okay. So in other words, when it's 31, I'll have 31 minus 30, 1 mile extra, $6 for that mile, right? If it was 32, it'd be 32 minus 30. I'd have $2 extra. It would be $6 for those 2 extra miles. So this is what I do if x is greater than 30. Okay. There is my piecewise function, and we should be able to see that pretty easy. This is a really expensive rental van because those miles extra over 30 are going to add up really fast. The second part says, determine the cost of driving the van driving 77 miles. Okay. So basically they want us to write the piecewise function, which we just did. Okay, that's the first part of the answer. And then they want me to use the piecewise function. So in other words, is 77 less than or equal to 30? If it is, then we'll use this first one. Well, no, it's bigger, right? So that puts it in this category down here. X is bigger than, because X is 77 here, right? X is bigger than 30. So that puts me on this second line. So remember when we did these before, I was like, just cover it up, cover up the one that doesn't apply. So we need this guy right here. So it's going to be 65 plus 6 times, and we're going to have to be careful here because it's not 6 times the 77, it's 77 minus 30, right? That's my functional value of 77. So the function of 77 is equal to 65 plus 6 times, this is 47, right? Okay, so 47 additional miles, and I need my calculator. 6 times 47 is 65 plus 282, and that is $347. So like I said, this is a really expensive rental. $6 a mile is crazy for the additional mileage. But that's what it said in the problem, so that's what we're going with. Okay. All right. Find the inverse of the function. So I'm going to do 1 or 2 more, and that's it, because I am already running out of time here and running over on the time that I like to have for a video. So we're going to do 1 or 2 more. We need to find the inverse for sure. Okay, it's one of the things we learned how to do, and it will certainly be on the final exam for us. Find the inverse function, and remember this is the notation, f to the -1 of x. We're going to do number, I don't care. Let's do 12. It's a little bit more complicated than 11. Okay, and we'll work it out and see where we are. Okay, so it says f of x equals -4x plus 9 over -5x minus 2. It's going to be a little bit more complicated than the number 11, so we'll do this one instead. So remember what you do. Instead of f of x, we're going to call the left-hand side the y, okay, so that I'm using the x and y variables whenever I do all this. And remember, step 1 was switch the x and y. Okay, so instead of y over here, it's going to be x equals. Instead of x over here, it's going to be -4y plus 9 over -5y minus 2. It's more complicated because there's 2 values that I'm going to use for my y's here. Okay, so swapped them. Okay, cool. And then step number 2 is solve for y. So I'm going to have to get these y's together on one side. I can't do it whenever it's written like a fraction like that. So the first thing I'm going to do is clear my denominator. I'm going to multiply by what's down there, -5y minus 2. Whenever I do that, it's going to clear out on the right-hand side, but don't forget, whatever you do on the left-hand side, you have to do on the right-hand side. So I multiply here by -5 minus 2 as well. Okay. So over here, I've got x times -5y minus 2 is equal to -4y plus 9. Okay, remember that what we're after here is to get the y value completely by itself, because it says solve for y, right? Okay, get another sheet of paper here, sorry. Solve for y. Uh-oh. Here we go. All right, so I need to get the y values by themselves, but see here, it's being multiplied. So I need to go ahead and distribute that guy through so that I'll have individual pieces here. So x times -5y is -5yx, and x times -2 is -2x. I'm going to go ahead and subtract off because I can. This, or I'm going to move this 4y. It is being subtracted, so I'm going to add a 4y to both sides. I just want to go ahead and get it moved over. So I've got this guy distributed through plus 4y, and the only thing left on the right-hand side right now is a 9. Okay, so I did 2 steps in one there. Sorry, if it bugs you, go do them one step at a time and see what I did. Okay, now I've got 2 terms with y's in them, and I see that there's some stuff being multiplied by it. I'm going to want to divide that out, and the only way I can do that is to factor. So before I can do that, I got to get rid of this x guy that's in the middle. He's just hanging out and he's in the way, okay? So I'm going to add 2x to both sides of my equation. Okay, that'll have it go away right there. Okay. Running out of space here. So what I've got is on the left-hand side, negative 5xy plus a 4y. Notice that both of those terms have y's in them. That's good. That's what I want. And on the right-hand side equals, I'm going to put the x first, 2x plus 9, because we usually write it in descending order if we can. All right. Look here. They both have a y in common. I'm going to factor that y out, and hopefully that's what we see anytime we see 2 terms together that have a common guy. What that's going to do for me is it's going to allow me to say all this other stuff is multiplied by the y. So when I want to get the y's by themselves, it becomes a matter of, oh, okay, I just need to divide by whatever it's being multiplied by. And it's kind of a big term, negative 5x plus 4, but it's the same thing, right? So it's going to divide out. The trick is whatever I do to the left, I have to do to the right. So I'm going to divide that side also. Now look, hey, we managed to get the y completely by itself. And instead of having 2 y terms on the right-hand side like I started with, right? Remember this problem had the 2 y guys over here. Instead of that, I've got the 2 x terms over here. Okay, and then if you don't remember, the last step is to write your y, your new y, right? This is your inverse function, I should say, as f inverse of x. Okay, so we need to substitute it back out. So that's what it looks like, and that is my inverse guy. All right. So again, these have solutions on them. You can check your solutions in the back. The next video, for some reason, the test 2 material, I did a composition function, so I'm going to skip 13 through 16 right now. I don't feel like I need to do one of these word problems. On the test, you're probably going to have compound interest. I feel like we just did one of those on test 3, so I think you're going to be probably okay for that. So I want to do one average rate of change real quickly. So I'm very certain there will be an average rate of change question on your test, and I just want to make sure we're good at it. And again, I'm going to do, oops, I see 19 actually has a square root in it. So let me do 19. Okay, f of x equals 2x, and that's all square rooted, from x1 equals 2 to x2 equals 8. So what it says is find the average rate of change from between x1 to x2. And this was out of chapter 2.4, section 2.4. Okay. So if you don't remember these average rates of change, remember that basically what we're doing, this guy is not a line. This graph is going to look something like this because it's a square root, right? Okay, so it's a curve. It's not a straight line. But average rate of change, or as I call it, AROC, uses a straight line. We call it a secant if you go on into pre-cal and calculus, uses a straight line to estimate the slope It's really AROC, average rate of change, on a curved function. Okay, that is really what is all going on when we talk about average rate of change. Okay, so we are going to act as if this is a straight line. We know it's not. But look, if I draw a straight line right there and I pick 2 points like that, it's kind of close, right? That's the idea. This line is going to approximate what's going on with this curve for me, okay? So if you don't remember, basically, we used x1 equals 2, x2 equals 8 when we plugged those in. So the functional value for 2 is going to be the square root of 2 times 2. Okay, square root of 4, which we all know is 2. Okay, so this point is 2, 2. All right. And then the same thing for the 8. I need the y values. I'm plugging in x equals 8. I'm going to get out square root of 2 times 8, square root of 16. We know the square root of 16 is 4. So that point is 8 comma 4. Okay. And then even though we had those points on the curve, we're going to use them to find the slope of this secant line because that is the close approximation. So remember that m is y2 minus y1 over x2 minus x1. Once again, it doesn't matter which one I use for x1 and y1 as long as I consistently call this my first point. And I'm going to consistently call this my second point. So y2 is, in this case, I'm using it as a 4 minus 2. And the x2, I'm going to use an 8 minus 2. What you can't do is start down here for the y's and then start up here for the x's. You have to consistently start from the same point. That's what you got to watch out for. Okay, 4 minus 2 is 2. 8 minus 2 is 6. 2 6 is 1/3. There's my average rate of change. Done. It is the slope of the secant line, and we're going to use that to approximate the average rate of change on that curve. Okay, so that is the basics of what's going on here for test 1. If you look at the next video, there will be, like I said, a composition question on that one. I think I do number 15 out of the section 2.6 material. So go ahead and watch all 3 videos and good luck studying for your final exam. All right, thanks.